Hi there, this is another chance to look at exercise 5E for year 12 further maths. The second part, simply because we didn't finish last time, and I think we need to do a few more questions if we're going to be able to do the exercises. So, well, here goes anyway. I think I've got 4 questions for you in total. The first one is very similar to what we've seen already. It's just another look at this. So I'll do this quickly. It says we've got a cubic equation with real coefficients. Fair enough. One of its roots is this. So as soon as you know that, of course, I'm going to write 1 plus 3 over 2i. It's complex. It's got real coefficients. So immediately I know that beta is 1 minus 3 over 2i. So that's easy enough. Gamma, do I know gamma? The sum of its roots is 6. Well, I don't, but I can do alpha plus beta plus gamma, the sum, which is this plus this plus the gamma, and that has to equal 6. The great news is they cancel. So I've got 2 plus gamma equals 6. Gamma has got to equal 4. Alright, at least I now know what all 3 roots are. So what's it say? Find the values of alpha, beta, A, B and C. So I can simply just add these roots up. So what is the, well, I know the sum already is 6. I need to know what the pairs are. The pairs, of course, are alpha, beta plus beta gamma plus gamma alpha. So let's do those. I've got to do alpha beta, so it's that times that. 1 plus 3 over 2i. 1 minus 3 over 2i. Plus beta gamma, so it's those two. So plus 4 lots of 1 minus 3 over 2i. That's easier to write it like that. And then gamma alpha plus 4 lots of 1 plus 3 over 2i. I think we'll get some things cancelling there. So what's this equal? I'll give myself some extra room. That's 1. And the great thing about this, you get 3 over 2i, 3 over 2i, 1's a minus, 1's a plus, they disappear. So therefore you get, well, on the face of it, it looks like minus 9 over 4 with a multiplier out, but it's an I squared, so it's plus 9 over 4. Plus 4 plus another 4, so I'm going to write plus 8. But I notice I get minus that and I get plus that, so I think actually that's right. So that's, what's that? 9 plus 2 is 11 and a quarter, which I think is 45 over 4. That's the pairs. What's the product? Now I've got to multiply them all. So the great thing is when you multiply them, alpha, beta, gamma, I already know what alpha, beta is. Alpha, beta was this part, which was this part, which was 9 over 4 plus 13 over 4, if you like. But of course, I've still got times by the gamma. And what was the gamma? The gamma was 4. Well, that was handy, because when I times those together, I get 13. So I now know the sum was 6. I know the pairs. I know the product. I reckon the equation is x cubed minus the sum 6 x squared plus the pairs. Pairs is 45 over 4 x plus 13 equals 0. Now normally you just times everything by the denominator, so 4x cubed minus 24x squared plus 45x plus 52 equals 0. I think. Minus 24, 45, minus 52, and that's because I forgot to change the sign, because it does say here, so minus the product. Silly boy. Other than that, you can see it works. Happy with that. Now look, these are different. This is the main reason I decided I needed a second video. So the quadratic equation is 3x squared minus 4x plus 7. Has roots p and q. Find the quadratic equation with the coefficient p squared and q squared. Now look, if I'm going to do this, I've got to first of all go back to my ideas of what the sum and the product. Now notice this is a quadratic, so I only get the sum of the product. And we've said, well, normally it's alpha and beta, but now it's p and q, so the sum is p plus q, and it's equal to minus b over a. So therefore, p plus q, what is? Well, a here is 3, b is minus 4, and c is 7. So minus b over a is minus a minus, so it's 4 divided by 3. And pq, remember, is c over a. So therefore pq equals, well, what do I need to do? Well, I need to do 7 divided by 4. Divided by 3, sorry. So we've got the these two things, and what I need to do is then say to myself, well, what's the new sum and the new product have to equal when you get a new equation with p squared and q squared as the roots? So this is different. Notice I want a new quadratic equation, but with related roots to the first, but p squared and q squared. Well, not surprisingly, p squared plus q squared is the new sum, and the product becomes p squared q squared. And I think we've seen tricks for these before. We said p squared plus q squared is the same as pq, p plus q, sorry, squared. But then I remember having to take away, because this gives me 2pq in the middle, I have to write minus 2pq. That was one of the tricks we learnt before. And this can be written as pq all squared. So both of these now can be rewritten, because I know what p plus q is. It's 4/3. So it becomes 4/3 squared minus 2 lots of pq, which is 7/3. And pq squared, I'll work that out in a bit. Pq squared is just 7/3 squared. Okay, let's work these out. Might as well do it with my calculator. I don't want to make dark mistakes. I've got 16 over 9 for the first one, minus effectively 14/3. I get minus 26 over 9 for this one. And this one's a lot easier, of course. This is 49 over 9. And so using this formula down here, I get my new quadratic equation with roots p squared and q squared will be x squared minus the sum. Well, it's minus the minus, which is 26 over 9. X plus the product is 49 over 9. Make sure you write equals 0. But we're just going to transform it and times everything by 9. You get 9x squared plus 26x plus 49 equals 0. Hopefully they're the right answer. Yes, they are. Perfect. This is new. This we have not seen before. We've used this. We've used these tricks, and now we're using both of them to get quadratic equations which are similar to the first one. Similar roots, related roots. Here's another example. So we've got PQR. This is a cubic this time. Notice I want 3P, 3Q, 3R as the roots of a new cubic equation. Just do it the same way. Write down the sum, which is P plus Q plus R. And, well, A is 1, B is minus 3, C, oh, be careful, there's no C, and D is 2. So this is minus B over A. So this is 3. It's nice that it's 1 there. And then the pairs, PQR, oh, PQ plus QR plus RP. And the form of that is C over A. Now C is 0, so this is 0. And then the product, which of course is PQR. That's D minus D over A, which is minus 2. Well, at least they're nice numbers. Now, I've got to go over here and say, well, what's the new sum going to be? My new sum is going to be 3P plus 3Q plus 3R. So that gives me 3 lots of P plus Q plus R. And of course, I know what P plus Q plus R is 3, so this is 3 times 3, which is 9. What's the new pairs equal? Well, that equals 3P times by 3Q plus 3Q times by 3R plus 3R times by 3Q. And I reckon all of those are 9 lots of PQ plus QR plus RQ. RP even that should be, shouldn't it? Nearly made a mistake. Luckily all that is 0, so 9 times it is still 0. That was easy. And the product, well, I've got to times them all together. This is 3P times 3Q times by 3R, and I reckon that's 27 lots of PQR. What was PQR was minus 2. I reckon that's minus 54. It's a very nice number there at the end. But of course, now we've got this, we can chuck it into our equation. X cubed minus the sum of x squared. The sum is 9. Minus 9x squared. Plus the pairs. Well, actually, it's none, because that was none there. So, and then minus the product. Luckily, I've got the minus 54. That's minus a minus, so it's plus 54 equals 0. I think, actually, that's the answer. No adjustment required. That is right. One last example of this. The equation 3x cubed minus 5x squared plus x minus 3 has roots alpha, beta, and gamma. Find the cubic equation with these roots. Okay, then. Do the same trick. Find the sum, first of all. That's alpha plus beta plus gamma this time, since that's what they've called them. That's what we'll use. It's minus b over a. Well, a equals 3, b equals minus 5, c equals 1, d equals minus 3. So it's minus b over a. I reckon that's 5/3. The pairs here are alpha beta plus beta gamma plus gamma alpha. And that is equal to c over a, which is 1/3. And then the product, should we get the hang of this now, the product is alpha beta gamma, and that is minus d over a. That is minus a minus 3. That's plus 3 divided by 3. I think that's 1. And of course I now need to find a new one. It's got these slightly weird looking roots. New sum is alpha beta plus beta gamma plus gamma alpha. No, actually that's perfect, because that's what we've got. This is this. I know what that is. That's a third. So the new sum equals a third. The new pairs. So I've got times that by that and so on. So that gives me alpha beta times by beta gamma plus beta gamma times by gamma alpha plus gamma alpha times by alpha beta. There's a lot of symmetry there, isn't there? So what do I get? I get beta squared in the first one. Or I could actually just write this. I'm just looking at this. And I'm going to write it alpha beta squared gamma plus alpha beta gamma squared plus alpha squared beta gamma. And you can see I've got alpha beta gamma in all of them. So I'm going to take that out as a common factor. And then I've got a beta, a gamma, and an alpha. So I'm going to write alpha plus beta plus gamma, changing the order slightly. And that's great news again, because I know what that is. Alpha beta gamma is 1. Times by the alpha plus beta, that's 5/3. So I've got an answer there, 5/3. And of course, I still need to work out the product. And now what's the product equal to? The product, of course, is these things all times by each other. Alpha beta, beta gamma, gamma alpha. I reckon if you do that, you get alpha squared, beta squared, gamma squared, which is definitely best written as alpha beta gamma all squared, which is 1 squared, which is 1. There's a lot of work to get 1. So what's my equation? My equation is x cubed minus the new sum, which is 1/3 of x squared, plus the pairs. What's the pairs? So it's 5/3 of x minus the product. What was the product? It was 1 equals 0. And of course, usually you would times everything by 3 in this case to get 3x squared, x cubed minus x squared plus 5x minus 1. Oh, minus, got times by 3. Nearly went wrong there. Minus 3 equals 0. So what my answer is meant to be? Oh, they've just left it as that. But I've got that right, and I've now got that right as well. And in class then we need to practice. This is quite tough on the cubics, much easier on the quadratics. There's actually another method as well, which I'll look at exercise 5F. But this is quite tough with the quadratics. So in class we'll do exercise 5E, page 159. Cheers guys.